Deb, you hear me? Yeah. Okay. Good morning, everyone. Hope everyone is healthy and you know surviving the virus. Diversified is operating under the CDC guidelines. Our shop has been open since March. As an essential product manufacturer, and we're hoping to get through this. So things are starting to. We see a lot more activity, a lot more people going to work. So hopefully things are looking up. So with that, we're going to start our engineering series webinar on indirect water heating products. So Diversified we have over 80 years of operating experience, over 200 years of combined, management and just product knowledge in our company. We have highly skilled personnel. Our quality system, has been ASME Section 8 Division 1 for probably in one shape or fashion over 50 or 60 years. And we pride ourselves on our customer loyalty as well. Just a little bit of a timeline for the company. It actually goes back even before 1938, but for purposes of this presentation, 1938, we were making potbelly stoves at that point, coils for potbelly stoves. The Lindy coils are being introduced at that time, shell and tube heat exchangers, and we had the formation of central tankless coils. Fast forward, 40 years of operating as two separate companies, Lindy Coil and Central Water Heater Company in New York City formed Diversified Heat Transfer in 1984. And at that point, we were manufacturing two bundles, HVAC coils, complete shell and tube heat exchangers. We had our indirect water heaters for residential with titanium. And we were also manufacturing the commercial water heaters at that point. And then in 2012, we moved our corporate headquarters to Tuaco, New Jersey, out of New York City. So for that period of time, we were always in New York, and we moved to New Jersey in 2012 for more space, more loading docks. We put in cranes here, paint booth. So, just a lot more added to the facility to make us more efficient. At that point, we introduced the super plate type water heater, our super therm steam-fired water heater, our clean steam generator, super steam. And in 2019, we introduced our STP Series with new controls. And in 2020, we're also introducing the TX Series and the SP Series. And then we also have some different applications for the STP with our new STP product with heat recovery. So as you see here, this is the product array. We have our ST Series steam-fired water heater, SP Series, our plate type unit, water to water. STP Series water heater is newly 2019. We introduced that. Our clean steam generator, super steam product. We have a line of storage tanks. glass lined and duplex stainless. And then we also have our plate and frame, AHRI certified. We go from 1-inch ports up to 24-inch ports. Brazed plate heat exchangers that we use for our SP Series, double wall. And we also have single wall, nickel brazed. Connection sizes go from 1/2 inch up to 6-inch ports on the brazed plates. We continue to manufacture for the replacement market, HVAC coils, all different types, steam distributing, chilled water, hot water coils, evap coils, so a wide array of HVAC coils for the replacement markets. And then we have our shell and tube line for the industrial type, and also we make our shell and tube for the ST steam-fired water heater. And the shell and tubes go from 4-inch in diameter up to 40-inch in diameter, and we top out about 30,000 pounds. So, we're manufacturing for the, chemical, refining, power, just other industrial applications for shell and tube heat exchangers. And as we said before, we have the Lindy tankless line. These coils go in the upper part of the boiler, and they can provide domestic hot water up to 12,000 GPH. So we're going to look a little closer at our SuperTherm ST Series. It's a fully packaged solution. It can fit through a doorway. It has modulating controls to modulate the steam, and we do that through our PID electronic controls. Here you see our current panel that we're using, proportional integral derivative control panel. And it also features our heat exchanger, diversified heat transfer, ASME heat exchanger. The warranty on this product is 10 years on the shell. It's 316 stainless, 5 years on the tube bundle, and 1 year on all the other components. And, we do have different configurations. We have a tank type VTSI, as you see here. So it has some storage, typically around 80 to 100 gallons of 150 gallons of storage in this standard type unit. And then we can go into custom units that have larger storage capacities, whether they be vertical or horizontal types. But these are custom units. The standard configuration for the vertical or horizontal unit is 6, 8, 10, and 12. The heating source is steam or boiler water or high temperature hot water for different facilities and schools in the Northeast. Single and double wall tube bundles. On single wall, we're doing copper, copper nickel, and stainless. On double wall, we do copper and copper nickel only. Control valve options are pretty much our standard, is going with the electric valve. There are some instances where the client wants pneumatic, and we can still provide pneumatic solutions. Again, the shell is stainless steel, fiberglass insulation, and our standard working pressures go up to 200 psi. We can go higher than that. We can go up to 300 psi with a special design as well. Here, the lay down the components. We have our steam strainer where the steam enters. We have the strainer to keep any particulate from coming into the control valve. And we have mud legs in both areas to collect any of the heavy particles that can get through. We have a drip trap for any entrained liquid. Again, protect the control valve, protecting the tube bundle. We talked about our electric valve. The valve fails closed. It's a spring return, not non-capacitor type. Siemens control valve, very reliable. And then we have our heat exchanger we talked about. We have our water dump. So if we hit a temperature on our secondary alarm, the solenoid will dump hot water out of the unit. Then once that condition clears and the temperature goes down, the solenoid will close back up again. We have our T&P relief valve, pretty standard. Both these items should be piped to a safe drain. And also the condensate coming off this unit has to drain by gravity, very important. So yeah, here's a sneak peek at our new design, ST2, that's going to be coming out actually next month. New touchscreen user interface. We have communication with the BACnet without a gateway. 200 psi rating for the heat exchanger is standard. And we've done some things with our bundle to optimize our performance. So we're going to get more performance out of a given diameter size on the heat exchanger. So that's also a benefit. Our wiring harnesses, we've redesigned, made them more sleek and just a much better, lighter design. We're also considering, we're shipping cross country. We're going to be removing some of these components just to make ease of shipment. And also, as you see here, for places where they're not returning the condensate, they're dumping into a drain. Here's our economizer. This lowers the temperature of the condensate, and also we pick up heat and we raise the temperature of our incoming water by preheating it with the condensate that's going to the drain. So it serves two purposes: lowers the temperature of the condensate to a safe temperature before it goes down the drain, and then we preheat our incoming water from, let's say, 40 to 60, 70, 90 degrees, depending on the flow rates. But yeah, it's a really compact design. Here you see our horizontal ST for areas or basements where they don't have a lot of clearance overhead. And here are the two designs side by side. Again, this is launching next month. New control panel, just enhanced heat exchanger design, new stand, different nozzle configurations, flanged. We're just trying to go, and it's all stainless steel. We're trying to minimize the amount of threaded connections going to the flanges. Just a much better design that we feel is going to be very competitive out in the field. We move on to our SP series, and we see around the country this product has been introduced for about 10 years, and we just see the amount of steam systems that are being replaced by boiler water systems around the country with let's say the condensing boiler type product. We have developed the SP series, our super plate. So this can come in a double or single wall configuration. Also in brazed or a plate and frame, depending on the capacity. We can provide it with a brazed plate or a plate and frame. And this is our product as well. So, we can control the spares on it out in the field. It ships completely skid mounted. It takes up a small footprint. We've got a powder coated base and stand, very durable, very tough, and for tough basement environments with, flooding and dust. It stands up pretty well, or you can wipe it down. We also have our all stainless steel manifolds and all carbon steel manifolds welded, again, minimizing the amount of threaded connections that we have. We have studded ports for the heat exchanger connections, and we've just done some real good field studies and done our homework on what works best, and we feel that this is a real solid design for us. It can make 140 degree domestic water with 145 degree boiler water, so we can get a real close approach for our performance. Very sleek design, very efficient design. It's ASME code tested. The heat exchanger carries a 5-year warranty, and all the other components have a 1-year warranty. And as you can see here, it features our touchscreen panel. So it has both the HMI panel, human machine interface panel. Makes it a lot easier for the operator to use this. And there's a lot of other benefits as well. The water-to-water heat exchanger, as I said, it's a braze plate. So, just here's a close-up of the braze plate. And as you know, you can't take this apart. It's a solid. If it has 50 plates, it's brazed with 50 plates. So it's a series of stainless steel, copper, sandwiched together, and then it's furnace brazed, to make it leak tight. And that's the construction of the brazed plate unit. It can really just be chemically cleaned or backflushed. The gasketed type, obviously, can be taken apart, regasketed. Any of the plates that are leaking can be replaced. You can even add plates to it for more capacity. So, it's a little bit more versatile, and you can get larger capacities with this. Again, this is a DHT product, carries a DHT nameplate, and it's AHRI certified as well. So that's another, good specifiable feature. Here you see, all the components. Again, we talked about the base. There are some brass components, low lead or no lead components. We do meet the NSF tabulated lead-free percentages. So by calculation, we can do that. And this unit also has the feature of feed forward and feed back. So basically, the domestic water coming in and recirc water coming in hits this sensor. That signal and that temperature is fed to the control panel. And then as the water travels through the plate and frame, some of it goes to the recirculation line and back through the heat exchanger for low demand times to keep the heat exchanger stratified, keep water moving over the plates. Then the water passes by the feedback thermocouple, and that signal is also sent to the controller. The two converge on the best solution for the control valve to move to maintain a very accurate temperature, plus or minus 2 degrees. Very solid controls. The control valve is a fast-acting 2-second valve, 1000-to-1 turn down, electromagnetic. So it's very accurate temperature control on this. Now we move to the STP Series. This came about, just a lot of people wanted some storage capacity with the super plate, so those were shipped separately, and we were going through that for a few years, and then we decided to come out with a new product where we package them together. And as you see, this is a very good solution where we have the heat exchangers mounted on the side of the tank to take up the least amount of floor space. And we know that's for engineers, that's a big deal to save floor space in the mechanical room. These units have recovery rates from 600 up to almost 11,000 GPH with 180-degree boiler water and 100-degree temperature rise. Standard tank sizes range from 175 to 500 gallons. We do have special order 765 gallons up to 1,000 gallons. And the typical domestic storage water temperature, we can store it up to 180 degrees, and then it can go through a blending valve. It can go to different parts of a kitchen, let's say, for hotter temperature water for the dishwashers and pot sinks. And then, it can be blended down to lower temperatures for human, interaction. This really just has the double wall braze plates, either a simplex or duplex design. As you see here is the duplex, but we can't do this with plate frames. This configuration, it's just too bulky, but we can do it with even our largest 260 plate braze plates. We have done this before, and it's a real sleek design, compact footprint. And it features, again, the new control panel, which you see here, and it has all the features of that, with tying into the back net without a gateway. If you're running Modbus, you can plug right into it, because that's its protocol, its base protocol. So as you can see here, there's a few configurations on how we control this. Either with a control valve typically, or a VFD pump. We can cycle that on or off. You see the tank as well. So the temperature control options are either the VFD pump or a 2- or 3-way control valve. We also have an option where we leave off the control valve and the pump. We just let the boiler water feed through the heat exchanger continuously. I mean, if there's another control on that pump, so be it. But typically, this can be running all the time. We have an aquastat. We get rid of the PID control. The aquastat controls the temperature in the tank, and then if it's too hot or too cold, we cycle these pumps on to circulate water through the heat exchangers, while the boiler water is continuously flowing on the other side, so we get the proper heat transfer whenever we need it. I mean, it's a simple control, it saves some money, but you lose the alarm controls, you lose all the communication with the building, so it's just another option. The standard material for the tank is carbon steel with a double glass line. We offer power anodes in the carbon steel tank, so it'll have a red and green light on it. So if it's green, it's fine. If it turns red, it's time to change the anode. It's a good, just visual for people, because most people forget the anodes, and it's too late. The anode is consumed, and then it's eating into the tank by the time anyone realizes it. So this is a good option. We also have duplex stainless steel on all our tanks in all sizes as well. That's an option for that. Again, we talked about it's fully packaged. We have unions and Vitalik connections, so the heat exchangers can come off easily for chemical cleaning, or you can clean it in place and back flush it. The heat exchangers carry a 5-year warranty. The double glass line tank has a 10-year warranty, and the duplex stainless steel has a 15-year warranty. All other components have a 1-year warranty. So we talked about our domestic water heating applications and the sizing overview. So we have instantaneous water heaters, semi-instantaneous water heaters, and storage water heaters. We'll talk about that a little bit. So the instantaneous type, typically the water is in the tubes, and the steam or the boiler water is on the shell. The hot water outlet temperature and steam input can be unstable. It fluctuates a lot. The hardest demand on the boiler of all 3 types of units is this type, and it requires a sophisticated mixing valve, because we're heating water here to 190 to 200 degrees, and then we blend it down with introducing cold water against the hot water to get the temperature that we need. So on this design, the semi-instantaneous design, the ST type design, we have water in the shell. It's much better for just more turbulence inside the heat exchanger, larger spaces, whereas when you have the water in the tubes, it's very prone to fouling on that type of design on the instantaneous. There's less chance of fouling having the domestic water on the shell side. So we have the steam or boiler water in the tubes, and the hot water outlet temperature is very stable. Steam input is stable. We modulate it with this valve, so we're constantly modulating the steam with the trap to maintain the proper temperature of the water, leaving the unit. And this has about 7 or 8 gallons typically. No, there is some storage in there, but typically it's very it's semi-instantaneous. And then we have our storage water heater, which there's a tremendous amount of tanks that are still out there, still in use. People like them because if they ever lose their boiler, they still have hot water for a couple of hours before people start complaining. So it can, have an interruption in the steam supply or boiler water supply, and it can still, supply hot water to the hotel occupants or the tenants. But it takes up a lot of space in the mechanical room. It's very expensive to replace. It loses, if it's not insulated well, it can lose a lot of heat into the room. And then also, they are easy to control because you have a large mass of water, so the temperature changes very incrementally as there's a large load put on it. The recovery time is relatively stable on it, and the hot water temperature and steam input are relatively stable, and it's much less. Smaller amounts of steam are required because the energy is already into the storage tank. One issue with this type of large stagnant body of water, of course, is the Legionella. So, when you have that temperature drifting below 122, you can get the formation of Legionella in the tank, so it is dangerous in that respect. It just, there's not a lot of turbulence, so it's conducive to the growth and sustaining the Legionella in the system. So we talk about the piping diagrams, and the installation of the typical SP unit. And this is how we'd like to see, the unit installed. Again, our scope of supply ends at these isolation valves right here. All this piping, the expansion tank, the backflow preventer, all these check valves, are all the balance of, the contractor's responsibility. But it is shown here in this diagram as a proper installation. It's just good practice. It should be on a cement pad, housekeeping pad, 4-inch, 6-inch, whatever specifications call for. And then, of course, in most schools, universities, hospitals, apartment building, we want to have redundancy. So we're going to have 2 units installed, and typically we like to see the reverse return on the piping. So the first unit to receive cold domestic water should be the last unit to deliver domestic hot water to the piping system. So the units are balanced and not, have flow going through only one unit and starving another unit. Or we do center fed manifolds. So we want a balanced flow for each unit. And, we talked about the storage. We feel that anytime we're working with commercial laundries or commercial kitchens, that have, high capacity machines in them, we need to have some water up front, in storage. So we recommend, putting, several hundred gallons of water in front of these commercial type laundry machines and dishwashing machines. It's just a much better design, and it keeps these large dump loads from affecting the performance of the unit, especially if it's tied in with other parts of the building. So we want to have that type of storage in front of the unit. Here is the diagram, the standard installation drawing for a super plate with a storage tank. And, this is what we're working on, for these type of units. Large hotels, which, hopefully are coming back. People are going to start going to hotels soon. Apartments, condominiums. We're big in the colleges. We have a lot of super plates and super therms at different universities. Healthcare, hospitals, mainly steam units. They are introducing some of the plate type units as well. Fitness centers. We talked about commercial laundries, industrial emergency showers, restaurants. And it's just a full gamut. So all the reps have access to the DHT online program where we can, either put the fixture counts in from the engineer, or if the engineer has already calculated the flow rate that they want, we can, the rep can put that through the program, and depending on the boiler water temperature or steam pressure, can come up with, the design of the unit, and with a submittal that we can send off to the engineer for review. So that system or that operation has become very streamlined with diversified online tools for the reps and all the resources that are on the website as well. So we talked about new installations. The load demand is given, or the fixture count is given. Either way, we can determine that the load for the unit, or if there's a project schedule and specifications, the rep can work with that as well from the engineer. Retrofitting of installations for replacing an existing DHT unit. We obviously would know the performance of that unit. So, and if you wanted to add, the building had an extension put onto it, or more apartments put onto it, or a hospital put on another wing, and they needed more capacity. So we'd need to know that. We also have the files on, pretty much all the competition. So we know if we have the model number from there, we can match that performance as well. Taking out a storage tank with a semi-instantaneous unit that's going on all the time. NYCHA has done that. New York City is doing a lot of that replacement work for just more efficiency and better energy design. We would need to know that information to make sure there's no load variations, and like we talked, any building expansions we need to know about. So yeah, when we're doing that, our curves are based off the Hunter curve and then the modified Hunter curves, and then we've also tweaked that a bit, and we know that the residential Hunter curves have already been modified by ASPE, and now they will be modified by ASPE again on the commercial side. It's going to take a few years, but we went ahead and made those modifications in our program, so that sizing reflects that. But a lot of the introduction of low flow fixtures in buildings nowadays, all these curves that you see here are going to be coming down because just the fixtures that they have in the buildings don't flow, have the flow rates that they used to with the older type fixtures. They're much more efficient. They just don't put out as much water as the older fixtures. So again, these curves are coming down, so we won't have wildly oversized water heaters. So here's our control overview. This is our current controller. You see here with the printed circuit board, we had a even larger control panel for some of the units that are in the field. You might see we condensed that with a printed circuit board. We put our transformer there. Again, this runs off a Modbus, so if you're running Modbus, you can plug right into this port right here. If not, you can add the field server gateway to communicate to BACnet. So, yeah, the BACnet system monitors real-time data from the water heater, the outlet temperature and the valve stroke position on the front panel. And that it's not a touch screen; it's the regular, pressure buttons. Very reliable system, and we have, thousands of these out there already. This unit also features the dry contact, so if the hospital has a protocol where they want the dry contacts for alarms, and they also want the BACnet system, if their building management system goes down, they can still read the alarms through the dry contacts. So we have that, dual capability. And then you see our new controller, which will be on the ST unit, SP, and STP. So this is the panel that you will start seeing next month on pretty much all our units. So it's HMI, human machine interface touchscreen, really lit up. No one else has this. It's a large screen. We feature the data logging on this unit. So we can log up to a year's worth of data. So if someone says they got scalded, we can see, that the temperatures have never gone above what the set point is. Conversely, they say there's low water temperature and it's, maybe causing Legionella. We can also check the data logging for low temperatures as well. Has the fault log for seeing any of the faults on the system. We can do trending and graphing of the temperature as well. Talks Modbus, so if you have Modbus in your building, you can plug right into it. And then if you need to hook up to BACnet, you can do that without a gateway. So that's really efficient, and and it's in the NEMA 4 enclosure. We can run 120 and 240 voltages, and then it also has something that no one else has on the market. So it has this screen here, the HMI screen, typically used, and this screen actually goes into sleep mode to save the screen when it's not in use. But also, if this screen goes bad, we have our backup screen inside the unit that can run the unit as well. So we have something that nobody else has as a backup control on it. So that's pretty much it. I'm not seeing anyone typing any questions, so this would be the time to ask questions if you have. Again, I hope everyone is getting through this COVID episode that we're going through, and everyone's going to be going back to some normalcy at their jobs, and we're going to be at the ASPE show in September in New Orleans, so that's coming up. Hopefully that, right now we have all indications that show will go off, and hopefully the attendance will be good. And then we have our show obviously in January in Chicago, the ASHRAE show. It's a very big show for everyone when it's at Chicago. So we'll have our big booth there. So please, if you're attending, stop by our booth. We'll be, putting out on LinkedIn more information on that. And incidentally, please, like and share us on LinkedIn, the DHT account. Very important because we have a lot of updates there. New product developments. Different jobs that we're working on. Just basically the best way to keep in touch. And then we also have the website. It's a very good source of information and tools for engineers, end users, contractors that we like to keep informed about all our products And if you have any questions, please type in. Otherwise, you guys have a good day. Thank you for attending, and be safe. I'll leave it open just for a minute or so if I see any questions. Okay, so if there's no questions, I'm going to sign off. Everyone take care. Thank you.